All right, guys, welcome to chapter 5, 6. It's kind of a weird chapter. We're kind of combining two chapters in one. So we're starting out with different like relationships in triangles because we just got done kind of talking about triangles. So we're going to kind of keep that train rolling. And we're going to talk about different lines that you may see in a triangle. So first thing we have to talk about, well, today the main goal is to be able to talk about and be able to solve equations and problems with perpendicular and angle bisectors. So your assignment today is going to look like, it's going to have two different like kind of worksheet looking things, and one's going to have perpendicular bisectors, one's going to have angle bisectors. They're both bisectors though. So what a bisector is, it bisects, which means it is going to cut something, and I'm saying something because we're going to deal with angles and segments. It's going to cut something in half. So what that means, it's going to cut something into two equal pieces. So you're going to be setting a lot of things equal to each other today. So that's what a bisector does. It cuts something into two equal pieces, or it cuts something in half. So perpendicular, I'm sure you've heard of perpendicular lines. It's where two lines come together and form a 90-degree angle. So that's basically what perpendicular is, and we're going to be dealing with perpendicular bisectors. So perpendicular is when lines cross or intersect, I guess if we want to use the technical term there, at a 90-degree angle. And you know you have a perpendicular bisector when you see that little box. So, or you know something's perpendicular when you see that little box. So, what is a perpendicular bisector, and what does this actually look like in a triangle? So, what I'm going to draw, don't judge my pictures. So here is a triangle. 3 sides triangle. Now, if I draw this line straight down and draw that 90 degrees in, this is going to be a perpendicular bisector. So let's see, we have, let's just label this X, Y, Z, and we'll call that A. Why not? So if YA, that segment YA, is a perpendicular bisector. So it's perpendicular because of the 90-degree angle. It's a perpendicular bisector because what this also is doing is cutting this segment XZ into two equal pieces. So you see this going on. What happens is if it's a perpendicular bisector, it creates two congruent triangles. So we just got done with our congruent triangles unit. So what that means is if these two triangles, I'm switching colors to keep this interesting for you guys. If these two triangles are congruent, that means this side and this side are the same length. This side and this side are the same length. These angles are, everything's equal pretty much. Whatever this triangle corresponds to in this triangle is going to be equal. There's a ton of equal stuff. So you've got this and this are equal. Remember, you've got your shared side. We've got these angles up here. So basically everything would end up being equal if it's like corresponds, if it's a perpendicular bisector. So let's take a look at really what you're going to be using with this. So this example right here, example 1 says, what is the value of AD? So the ultimate goal is to be able to figure out what the length of AD is. Remember, like this is a side, kind of like when I did the pen thing. What's the length of that side of the triangle? So we have a perpendicular bisector because you see the 90 degrees and then both of these are 11. So because this is a perpendicular bisector, these two sides are equal. So to find the length of AD, we have to solve for x first by setting 6x minus 10 equal to 3x plus 2. Because remember, if it's a perpendicular bisector, the corresponding pieces are going to be equal to each other. So then use your awesome algebra skills. Let's see here. 3x minus 10 equals 2. Add 10. 3x equals 12. So you get x to equal 4, which is awesome, but that's not what the problem wants. It wants you to find the length of AD. So now you have to take that 4 and plug and chug it back in. So AD is 3x plus 2. Take the 4 and plug it in. 3 times 4 is 12. 12 plus 2 is 14. So it has a length of 14. And that's it. Lots of algebra popping back up today. So then here for the try it, we have, here's your 90-degree angle. And then since these sides are equal, we would end up having two congruent triangles. And this one wants to know what's the value of WY. So once this is all said and done and I set them equal and solve, we're going to plug it back in right there. So we have 5n minus 2 equals 2n plus 7. Subtract 2n, add 2, and you have 3n equals 9. I did a quick shortcut there. I hope that doesn't throw anybody off a little bit. Divide by 3, and you get n to equal 3, which again is great, but that's not what the problem wants. The problem wants the length from W to Y. Sometimes they're going to ask you for the entire length, so you really have to pay attention to what it's asking. So for WY, I'm going to take the 3 and plug it in here. 2 times 3 is 6. 6 plus 7 is 13. Hopefully you're looking at this and thinking, okay, I can handle this. This is a good Friday thing for me. All right, last example. I kind of really like this one. So it wants to know ultimately what's the length of OL. So we have that these two sides are equal. Here's your perpendicular. So if this is 14, that means from N to L is also 14, but it only wants the length of OL. Well, you have another perpendicular right here, and if from N to L is 14, OL is going to be half of 14, which is 7. I like that one. That one's kind of cool. It looks more difficult than it really is. So those are perpendicular bisectors. Now, angle bisectors basically is going to do the same type of thing. So what an angle bisector is, you're getting a 2-for-1 deal on this Friday. What an angle bisector does is it cuts angles. So that's where those corners, where those two pens come together, it's going to cut this angle in half. And I spelled, yep, angle in half. So basically into 2 equal, there's your equal, which is all you're going to be doing today pretty much, equal pieces. It also creates the congruent triangles again. So like if I have an angle, there's my two pens coming together, and then here's my angle bisector. What the angle bisector does is it makes these two angles equal, and then you're always going to see it drawn like this. Like they're going to take the bisector and connect it and create the triangles. So like, and I hope you can see that. Here's a triangle, and here's a triangle, and basically everything on these triangles that correspond are equal. So like this is equal to this is equal to this, you've got the shared side, these angles are all equal to each other, everything's equal because of that. So let me show you kind of a couple of examples before I let you loose today. Example 2 says, what is the value of KL? So see these little markings right here? You got one, that means that you have a you have an angle bisector. So because you have an angle bisector, that means these two are equal to each other. And then when it's all said and done, they do want the length of KL, so we will have to plug it back in. So 4x minus 11 equals 2x plus 3. Subtract 2x, add 11. You get x to equal 7. Then you need to plug it back in. It only wants KL, so you're going to do 2 times 7, which is 14, plus 3 is 17. And again, don't forget, if this is like, if I maybe seem like I'm moving too fast, the best part about watching the videos, you can stop it, pause it, rewind it, all that fun stuff. Then for the try it, okay, here we go. It says, if HI is 7, IJ is 7, so that automatically tells us that this is going to be an angle bisector because we have we have some equal angles and equal sides. And then it says HGI, this angle is 25. What is the measure of IGJ? Well, if this is 25, that is going to be 25 as well. Easy peasy lemon squeezy. And then we're not going to do this one because I already wrote on my picture, and I don't like when I don't give you a second picture because now I'm going to throw everything off. So basically the name of the game today is just setting things equal to each other and solving. Please, though, make sure if you solve for X, go back to the problem and check and see if that's all it really wants. Most likely, you're going to have to plug it back in. Any issues, let me know. I think we have a quiz coming up upcoming Friday. Yes, next Friday, I'm sorry. Next Friday, a week from today, you will have another quiz. So if you're looking at your grade right now and you're like, oh, how can I fix this and make this better? You will have another quiz coming up, and you do have a test on March 2nd as of right now. So those grades will be able to change quickly, but you've got to make sure that you keep up on stuff. So any issues, don't hesitate to reach out, and I will be keeping an eye on those GoFormatives.